For question 3, the volume of a metallic cube of side length x cm is increasing at the constant rate of 0.108. Determine the rate at each the side of the cube is increasing when the side length reach 3 cm. And then find the rate which the surface area of the cube A is increasing when the side of the length reach 3 cm. So first of all, we read the questions, we identify our unknown, and identify the shape. So the shape here, they were stating this is metallic cube. Therefore, this is a cube shape. If the side length is x cm, so cube, length, width, and then height all is same, x cm, increasing at the constant rate. So the constant rate here is dx dt. Is increasing at the constant rate. As you can see here, this is your volume. So dv dt, the volume is increasing. So increasing the rate will be writing in positive value. Then we need to determine the side of the cube increasing means you need to know what is your dx dt. Therefore, our first step, shape already know, constant also we know, unknown only have one, which is x. Then second step, when we want to find dx dt, we use the chain rule. It can be dx dv times dv dt. Then for the third step, we're going to find dx dv. So we can start from the volume formula in terms of x. So it will be x cubed. When we differentiate v with respect to x will be 3x squared. Then dx dv 1 over 3x squared. Then number 4, we want to find the answer. We substitute inside the chain rule. And then what is the x here? They say the side of the length reach 3 cm means x is equals to 3. So here we have 0.004. This is cm per second. Then when we move to the second part of the question, which is B, find the rate at which the surface area of the cube means you want dA dt. So dA dt, we can start with dA dx and then dx dt. So what we need here is area formula in terms of x. So area for cuboid, it will be 6 times x squared because one surface area is x squared and then cubic will be have 6 of the surface area. So it will become 6x squared. And then when we differentiate a with respect to x, it will be 12x. Then we can substitute into the dA dt. dA dx is 12x. dx dt is equals to 0.004. We can take this value because it is in the same case when x is equals to 3. So this is the x when it is equals to 3, the rate of change at the moment x equals to 3. This is also the rate of change at the moment at x equals to 3. Therefore, dx dt can refer to this 0.004. Then another one is substitute the x here to be 3. So here we have 0.144 surface area, it will be cm squared per second. Alright, so we look at these 4 marks. First of all, differentiate v with respect to x. here will be one concept of the marks, and then reading out the DVDT value, then build out your chain rule and substitute your 3 here to get to the answer. Then when we come to second part B here, so differentiate the area with respect to x, use your chain rule and substitute your 3, and this will be answer. So here you have